Hi everybody, I'm going to show you how to complete our first lab. This is going to be on density. So first thing to do is to go to cell A2 and then enter your student ID. And then after that, then you can begin the lab. So let's see the different sections. So section 1, you're actually going to complete this as you're doing the lab. You're going to read the instruments. You're going to enter the instrument errors in section 1 here. And section 2 is just a definition of the terms that we'll be looking at. So mass is going to have the variable m, sigma m is going to be the area in the mass, volume is going to have the variable v, sigma v is going to be the area in the volume, and density is going to have the variable capital D, and area is going to be sigma d. So the lab actually is going to begin in section 3. So for section 3, you're going to measure the mass and volume of these materials here from gold all the way down to wood, and you do that by clicking on this link for Density Lab Simulation. And when you do, this website here is going to appear, and you're just going to click on launch. And so first, let's just go ahead and work with gold. So what you're going to need to do is to measure the mass of gold. So if you go over here and go ahead and set the fluid density to 1. And click on here for gold. And so first you're going to measure the mass of the gold. So I'm not going to drag it. I'm going to try not to have the number appear, but you're going to take that gold, you're going to place it on top of this digital mass scale, and a mass reading is going to appear. But this one, it'll pop up if I bring it too close. So once you put the gold onto the digital mass scale, you're going to get a mass reading here. And whatever mass reading you get, then you're going to enter that over here. And next, you also can record the units for the mass. So you're just going to click on this list here and make sure that you have the units and convert it into SI units. That's going to be the first thing. Next, you can measure the volume for that gold sample. So you'll click on the simulation. You'll click on gold. And first notice that if you just remove any, just click on the gold here. If you just remove it from the sample, that's you can see that number there, 25.5 milliliters. That's going to be the initial volume of water in the cylinder without any sample in there. And once you drop the gold into the cylinder, you see that the volume changes. So the actual volume for the gold is the change in volume here. So once you measure that, once you calculate that change in volume, then you're going to enter that over here. And again, make sure that you convert that into SI units. So you'll put that number here, whatever the unit is in SI for volume. So that's going to be for gold. Also, now you can go up here and actually get the values for the error for the mass and then the error for the volume. So the way to do that is you're gonna click on that computer simulation. So let me just pick a sample here. Let me just pick a random sample. So if I pick this one here, you place it on a digital mass scale. If you notice, looking at this reading here, the 8 does not, the last digit is an 8, it's in the hundreds place, and it's not fluctuating. So this is going to be the last non-fluctuating digit. And so you have to go back to the error analysis lecture and see how to define the error when you're looking at a digital device, in this case here for the mass scale, and all the digits that you're looking at are not fluctuating. So how do you find the error in the case when the last digit that you see is not fluctuating? So that's going to be how you're going to get the error for the mass. You'll have to look at the error analysis lecture. And next, you can also get the error for the volume. Here, just take that to be a digital reading, this 25.5. So this is going to be a digital reading. And again, here, the 5, the 0.5, the last digit is in a tens place, and that number is not fluctuating. So based on that, you can calculate the error for this reading. Even though you see these, I'm not considering this to be an analog device because you don't see any actual numbers next to these tick marks here, and they change depending on the mass. So I'm just going to assume that this is going to be a digital readout. And again, here, the last digit is not fluctuating here. So use the error analysis lecture to figure out what the error is for this for the volume. And once you get those two errors, then you're going to record those here. The error for the mass, along with the units for mass, and then the error for the volume, along with the units for volume. Whatever those are, just make sure that you got those in SI units. And then after that, you're going to finish off the rest of this table for ice, foam, lead, hard rubber, all the way down to wood. And if you go to the link, you'll see those materials there listed. And you just have to complete this table. And from there, you can go ahead and move on to the next section. So here, this gives you a formula. This gives you a set of formulas you're going to use here for. So for section 4, you have a set of formulas, and you're going to use those formulas over here in section 5. So for section 5, it's those same materials, aluminum all the way down through oak. And here you have to calculate the density of each of the materials that you measured. And so you're going to go ahead and use this formula here. So the mass, this is the measured mass divided by the measured volume, is going to give you the calculated density. And you're going to put that over here. Or I should say experimental is the same as calculated density. And you're going to put that over here. So next, you're also going to write here, insert the units for density, whatever those are. And so after that, here, this is going to be a calculation here. What you want to calculate is the error in the density. So let me zoom in a bit here. So to calculate the error in the density, you're going to use this formula over here. This is from the error analysis lecture. It's pretty much whatever objects you've taken. So here, you measured two things. You measured mass and you measured volume. So you're going to use those two to calculate the error in the density that you calculated. So then, for example, here, this formula says the error in one measurement divided by the value for that measurement squared plus the error in another measurement divided by that measurement squared. That's going to equal the ratio of the calculated value divided by the actual value. Let's see that again. It equals the error in the calculated value divided by the actual value. So here, what you'll do is you can say this is going to correspond to mass. So this is going to be your error here in your corresponding masses. So you're going to do that for aluminum. And then the other part of the formula that the second thing you measured was volume. So this here is going to correspond to this number over here, the error in the volume, and then divided by the actual volume. So what is the actual volume here? That's going to be this number here. So this formula you're going to have to use all four of these numbers here. It's pretty much going to be the error in the mass divided by the mass, and then the error in the volume divided by the volume. And then you'll have to square those and then add those up together and then take the square root. And then afterwards, you'll have to multiply it by this number here, which is going to be your calculation for the density, this value here. And then that's going to give you the actual value for the density over here, so the error for the density. So you're going to do that for aluminum. And then you're going to do that also for these other materials. So you're going to have a series of different densities. And density, well, the error in density is going to have the same units as density. So let me zoom out here. So the error in the density is going to have the same units as density. And next, what you're going to do is you want to find out this represents the accepted value for density. And the way that you're going to find that is you're going to click on this link on the side here. And once you do, a website is going to come up. And this website is going to give you a series of density or a list of densities for different materials. So you just have to look up the density. So you're going to, aluminum. So let's go ahead and look up the density for aluminum. And it's in alphabetical order. So right there, aluminum has this density, and make sure that you include the fact that all these numbers are multiplied by 10 to the 3. And you have the units right there for density. And then you just have to keep on looking. You're going to look up, I believe there's also steel and wax. So you just have to keep on looking for all those different materials. So there's lead is on that list. And so you're just going to have to find the densities for the corresponding materials. And then you're going to enter those accepted values over here into this column here. And don't forget to enter the units for the accepted values for density. So let me just restate that again. The experimental error, you're going to use, the experimental density, you're going to use this formula here. And for each of these densities, what you're going to do is to get the corresponding, use the corresponding measured mass and a corresponding measured volume. That's part one. And the second part is going to be the error. And to get the error, you're going to use this formula over here. And this formula involves 4 things, actually 5 things, but inside the square root, it involves 4 things. What it involves is the error for the mass and the mass, as well as the error for the volume and the volume. That's what's going to go in here. And you're going to use that to calculate the error and the density for each of the materials. And then the last part is to get the accepted density. And to get the accepted density here, you're just going to click on this link, list of densities, and it's going to take you to this table over here. And for each of the materials that you measured, then you're going to enter those densities. So don't forget that, like for example here, this is steel. So you see this number, this corresponds to the density for steel, but don't forget that each of these numbers has to be multiplied by, you can see right there, 10 to the 3 to get the right value. And so once you've completed the table, the last formula that you're going to calculate is going to be the percent error here. And the percent error is given by this formula. It's just the difference between the accepted and the experimental divided by the accepted and times 100. And you're going to enter those values here. So don't forget the rules for significant figures for errors though. All of these errors, this error here and this percent error, there's a requirement for the number of specific figures that they're going to display. So don't forget to include that as well. And that's going to complete the lab. That's all you have to do. Just measure the masses and the volumes, then calculate the density and then the error and the densities, and then compare those values. And now let's look at the homework. The homework is pretty simple. You'll click on the homework tab, and there's just 4 questions to answer here, and they're all from the drop-down list. So this concludes the instructions for Lab 3 on our density lab.